This video presentation will focus on the discovery of graphene and its potential applications. The Cambridge Dictionary defines graphene as a form of carbon consisting of sheets that have the thickness of one atom. The atoms are arranged in a honeycomb pattern. This exciting molecule was first discovered by Andrew Geim and Konstantin Novoselov at the University of Manchester in 2004. They were awarded Nobel Prizes in physics for their simple yet groundbreaking experiment. They had been using Scotch tape to clean a rock of graphite and found that the residue present on this rock had isolated graphene. Little did they know at this point that they had found the new exciting wonder material that scientists will further explore for various applications. The potential uses of graphene include transport, medicine, electronics, energy, defence and desalination. The range of industries where graphene research is making an impact is substantial. The simplest and most effective ways of discovering the true potential of graphene is to combine it with other existing products to create what we know as composite materials. It is thought that graphene could create a rust-free future by combining it with paint to form a unique graphene coating that could prevent the rusting of cars and ships. Graphene is also being tested to create weatherproofing and packaging, as the same principle for anti-rusting could be applied to the building materials for weatherproof houses. It could also be applied to food and pharmaceutical packaging, which would stop the transfer of water and oxygen molecules. This would keep food and perishable goods fresher for longer, and this may even help to reduce food waste and prevent illness. Within biomedicine, graphene-based materials have been used to create graphene sheets, graphene flakes and graphene oxide. They are currently being tested for and used in targeted drug delivery, improved brain penetration, DIY health testing kits and smart implants. Graphene may also be used in tissue engineering and antimicrobials. An experiment was done to prove that reduced graphene oxide contains antibacterial properties. Through the preparation of reduced graphene oxide copper oxide nanocomposites, the antibacterial properties of this compound were tested against a known pathogen called Pseudomonas aeruginosa. The composite displayed excellent antibacterial activity and led to complete bacterial inactivation on contact. This leads scientists to believe that this could perhaps be applied for the treatment of water systems. Graphene has also been used as a photosensitizer for tumour PTT therapy, which is deemed to be a non-invasive and highly efficient strategy for tumour therapy. Graphene is also currently being tested at the University of Manchester for its potential development to create graphene membranes. Graphene oxide membranes are capable of forming perfect barriers when dealing with liquids and gases. It is being explored for its potential application in gas separation, desalination projects and water filtration, which was previously mentioned. Another exciting application of graphene is its potential use in flexible and wearable electronics. It could create faster transistors, semiconductors, bendable phones and other electronics. It can also be used as a coating to improve current touchscreens for phones and tablets too. Light-emitting diodes or LEDs used in laptops and televisions are made by stacking metallic graphene insulating boron nitride. The incorporation of graphene can provide the basis for flexible and semi-transparent electronics which have a much better quality. Graphene would be more resourceful for high-use energy applications such as electrically powered vehicles, smartphones and laptops, which would also significantly decrease their current size and weight. Graphene has the power to charge a smartphone in seconds or an electric car in minutes. Despite this being a very bold statement, graphene batteries are being researched and offers a lot of potential that would greatly advance modern-day electronics. Graphene batteries could be produced and replace the traditional lithium-ion battery, meaning they would hold more power for longer too. These batteries have amazing superlative properties and would also be extremely flexible and light, and could even potentially be recharged by body heat. Graphene has also been tested for its use in sensors. Ultra-sensitive sensors made from graphene could detect minute dangerous particles, helping to protect dangerous environments. It is an ideal material to use in sensors, as every atom in graphene is exposed to its environment, allowing it to sense changes to its surroundings. It could also create micrometer-sized sensors that are capable of detecting on a molecular level. This could aid farmers in monitoring crops and could be beneficial to the agriculture industry. To conclude, graphene has many potential uses and offers a lot of potential in various industries. It is very likely that graphene will appear in more resources when the industries begin to utilise this wonderful material.